Please title these notes Application 7 Notes, Tricky Accumulation, and write today's date. By the end of this lesson, you should be able to do tricky accumulation problems involving extrema, estimating first and second derivatives, and multiplying equations. Let's start off with extrema and accumulation. This is combining the accumulation stuff that we've been doing with the graph analysis work. So the rate of change of the volume of water in a tank is given by V prime of t equals negative t squared plus 6t minus 8 in gallons per minute. There are 250 gallons in the tank to begin with. For our first problem, what is the minimum amount of water in the tank from 0 to 6 minutes? Okay, so we are interested in a minimum. So amount, that's by amount, we're really talking about volume here. So this is V of t from 0 to 6. Minimum comes from the increasing, decreasing line. And we're told about V prime of t, and also because we're using an equation, we have to have a plus minus line. And that lines up with V prime of t from 0 to 6. So now we need to take our V prime of t and use it to do our graph analysis just like we normally would. V prime of t is negative t squared plus 6t minus 8. If we do our factoring, so that would be t and negative t. And to get negative 8, we can do 4 and negative 2, and that works out fine. 2t plus 4t gives us that 6t right here. So V prime of t is negative t plus 4 times t minus 2. If you factored it differently as negative t plus 2 and then t minus 4, you'll get the same thing. Basically, you could factor out a negative 1 here, and you would have negative times t minus 4 times t minus 2. So if you distribute the negative to the other one, that's fine. So we'll find our zeros. Negative t plus 4 equals 0. 4 equals t. T minus 2 equals 0. T equals 2. And now if we pick our test points, number between 0 and 2 is 1. Negative 1 plus 4 is positive. Negative 1 minus 2 is negative. Between 2 and 4, 3. Negative 3 plus 4 is positive. 3 minus 2 is positive. And then 5. Negative 5 plus 4 is negative. 5 minus 2 is positive. So that means over here, decreasing, increasing, decreasing. We have potential minima at t equals 2 and t equals 6. So we need to find V of 2 and V of 6 and compare them. We know that how much water is in the tank at t equals 2 is going to be the initial amount plus the integral from 0 to 2 of v prime of t. We know that initial amount was 250 gallons. And then if we just plop this in the calculator, remember v prime of t is negative t squared plus 6t minus 8. We're going to get negative 6.6 repeating, or v of 2 equals 243.3 repeating gallons. Okay, so let's compare that to v of 6. This is the initial amount, 2. But now we're going to add the integral from 0 to 6 of v prime of t dt. And again, if we put that in the calculator, use finite integral, we get negative 12. This is smaller. So this means the minimum amount in the tank from 0 to 6 is 238 gallons at time t equals 6. We can also be asked something like this. What is the average rate of change of the volume of water during the time that volume is increasing? Well, from our work up here, we already have the v of t chart. I'm just going to copy it below for reference. We can see that v of t is increasing from t equals 2 to t equals 4. So that means that we're going to find the integral when the volume is increasing, so that's from 2 to 4, of v prime of t dt. We're looking for average rate of change, so we have to divide by that bound minus that bound. That's our average value of v prime of t. So this is 1/2 integral from 2 to 4 of negative t squared plus 6t minus 8. And if we put that into the calculator, that's 1/2 times 1.3 repeating, which equals 0.6 repeating gallons per minute. It's the same units that we had for v prime of t originally. These next problems aren't exactly accumulation problems, but they show up a lot in the free response sections with accumulation problems, so I wanted to go over them again. The table below gives the rate at which oil is leaking from a pipe in barrels per minute. So this is minutes, this is barrels per minute. Okay? So our first problem is to estimate the rate of change of the leak rate, R of t, at time t equals 13 minutes. So the leak rate, don't be confused by the multiple rate words, that's this rate at which, that's the leak rate. So the leak rate is just R of t, the rate of change. Remember, rate of change, we're talking about a derivative. So what it's asking us to find R prime of 13. It's asking us to find the derivative of R when t equals 13. Our best estimate the slope of the tangent line is the slope of the secant line through the points on either side. Remember, the derivative is the slope of the tangent line, so we're looking for the slope of the tangent line at t equals 13. And the points on either side are the points 10, 9 and 15, 16. So we're going to use those to estimate the slope of the secant line. (16 minus 9) over 15 minus 10. That's 7/5, or 1.4. And in the units, we're doing the R of t units divided by the t units. So barrels per minute squared. Part B. Is there evidence that the leak rate is increasing at an increasing rate? So we can tell the leak rate R is clearly increasing here, but is it increasing faster? And we want to know that because if it's increasing faster and faster, that means the problem is getting worse much more quickly than it otherwise would. Basically, the problem is getting worse. It's not just a constant leak that's happening, but it's quickly getting out of control, and something needs to be done about it. So when we're asking is increasing at an increasing rate, let's translate that into math. So increasing means the derivative is positive, and at an increasing rate means the derivative is increasing. basically that the rate of change, the derivative, is getting more and more positive over time. We can estimate the rate at which the leak rate is increasing by finding the slope of secant lines. Basically, the secant line between each pair of points is our best estimate for the derivative of the points in between. And so if we see that the derivative is increasing over time, that means that the leak rate is increasing at an increasing rate. So slope of the secant lines from t equals 5 to t equals 10, from t equals 10 to t equals 15, from t equals 15 to t equals 20. So from 5 to 10, looking back at the table, change in y is 9 minus 4 over 10 minus 5, that's 5/5. From 10 to 15, I'm still just looking at the table, 16 minus 9 over 15 minus 10, that's 7/5. 25 minus 16 over 20 minus 15, that's 9/5. So yes, the leak rate is increasing at an increasing rate because the slopes of the secant lines between each pair of points which estimate the rate of increase of the leak or rate of change keep increasing. The final question is, at a wire making company, the rate at which a wire is made is given by m of t equals 1 over t plus 1 in meters per minute for t is greater than or equal to 0, where t is time in minutes since the wire is started. To produce particular segment of wire, is given by C of t equals 0.1 t dollars per meter. What is the total cost to produce a wire for 4 minutes. Okay. So if we're going to find the total cost, actually let's let these be different variables. I'm going to make this D of t so I can let cost be C of t. So total cost is going to be the integral from 0 to 4 of the rate of change from 0 to 4, let's call it C prime, respect to time. And right now the cost to produce a particular segment is given in dollars per meter. Now, the thing that we can notice though is that if we need dollars per minute, and what we have is dollars per meter, if we have something that is meters per minute, then these meter units will cancel right out and we'll have dollars per minute. So what that means is that means we can do the integral from 0 to 4 of dollars per minute times 1 over t plus 1, which is, oops, excuse me, this was dollars per meter right here. Meters per minute, and the units will come out right. Notice that what this was is that this was d of t, and this was m of t. So we're really just multiplying them together. So now we can do the integral from 0 to 4, 0.1 t over t plus 1, plug that into finite integral, and we get 0.239 dollars. That concludes these notes.